we want to talk about naming ions and ionic compounds at this point. Okay? And it's not so difficult. You just have to know a couple of rules that are associated with things. So I'm going to write out metals on one side and nonmetals on the other. And I'm not going to talk about molecules just yet. I'm just going to talk about basic atoms. Okay? So if I'm going to name something that is a metal, that's an ion, okay? So suppose I've got sodium, Na+. You know that if I bind this to a chlorine, it's going to be sodium chloride, table salt. Okay, so nonmetal is Cl-. The good news is that let me use a different color here. That for metals, the name doesn't really change too much, for the most part. There's a couple of exceptions. But this is sodium. And notice I did not capitalize sodium here. Don't capitalize chemical names unless they are proper names. For example, when I hurt myself, what did I take? I took ibuprofen. It's a molecule, it's an organic molecule. Ibuprofen. Alright? If I go to the store and I look for ibuprofen, I'll find the generic, but the non-generic form of ibuprofen is Advil. Okay? If I'm looking for Tylenol, Tylenol is a brand name, so I capitalize it. But Tylenol is just acetaminophen. Okay, both of these are pain relievers. Alright? But both of these, one of them is Advil, one of them is Tylenol. Brand names have to be capitalized. Chemical names, not capitalized. You only capitalize it when it's at the start of a sentence, just like everything else in the universe, right? Okay, so make sure you don't capitalize that. So notice sodium ion is the same name as sodium metal. Easy enough. Everything's called sodium. All the metals are called what their ions are, for the most part. Some exceptions. Okay, but for chlorine, okay, this is chlorine, but when it gains an ionic state, it changes from chlorine to chloride. Okay, so the IDE represents the ionic form of that atom. Okay, so it's just ions, not molecular or anything like that. So let's see. So sodium chloride, this is NaCl. Okay, easy enough. Let's just do something else. Let's do KBr. Right? Hit pause and see if you can predict what this is going to be called. K plus is potassium. You're right. Potassium. And what is my ion going to be called? It's going to be called bromide. Good. All right. That's K plus. No, that's potassium. Sorry, Br minus. Okay, potassium bromide. Good. All right, let's go to something else. Let's do something a little bit harder this time. Okay, let's do CaO. Right. If calcium is completely ionized, remember that the Lewis dot structure of calcium is this. What's the most stable form that's closest to it? Calcium with 2 electrons, where's it going to go? It's going to lose those 2 electrons to get to its nearest form. So the most common ion of calcium is calcium 2 plus, right? So calcium's ionic form is calcium 2 plus. And what's that called? You guessed it, calcium. Oh, we're getting tricky, aren't we? Okay. But what about that oxygen that's attached to it? The oxygen that's attached to it, what's the charge on going to be? If I look at oxygen over here, how many electrons does it have to gain in order to have that full octet? So it looks like neon. Okay? It's going to gain 2 electrons. And once it gains 2 electrons, it's gaining 2 negative charges, so its overall charge is minus 2. So this is O minus 2. And what's that going to be called? That's oxide. Good. Okay, so that's calcium oxide is the name of that molecule. All right, let me circle all my charges here. Good. All right, Getting a little tricky now. Little tricky. Let's do this. MgF2. Right? What are the two charges here? Well, if you look at magnesium, it's in that second column, right? In that second column, everything's a +2. Just like in the first column, everything's a +1. So magnesium is going to have a +2 charge. And what is the name going to be here? Oh, it's tricky. It is manganese. No, not manganese. It's a different element. It's magnesium. Okay, but what about that F? I've got two of the F's now, because fluorine can only have a -1 charge. So my nonmetals here are F-1, and I've got two of them. Okay, now the important thing to denote is that for the fluorines, or for anything on these ionic compounds, if it's an ionic compound, we don't denote how many of these ions there are. So I don't put di or bi or duo or 2O or something like that on here. No, this is fluoride. Okay, that's fluoride, magnesium fluoride. So notice that sodium fluoride and magnesium fluoride have two different amounts of fluorine, but we both call them the same thing. All right? Let's try this. Let's go even trickier, and let's do aluminum oxide, ALO. And I'm not going to put down how many of each there are. The first thing I want you to do is I want you to look at these and tell me what the overall charges of these are going to be. If you look at aluminum, what column is it in? It's in the third column. So what do you think is going to happen? Is it going to want to lose 3 electrons or gain 5 electrons? That's right, it's going to lose 3 electrons. So the base ion here is going to be aluminum 3+. Now we've done the oxygen before, so I don't have to explain that again. But I've got oxygen. Okay. But notice what happens here. I've got +3 and I've got -2. Now I can't buy things from Aldrich or Fisher. I can't buy things. They're in their ionic form. It's just not going to happen. I can't have a salt delivered to me that has a charge associated with it because they're unstable. They like to react with stuff. So everything has to be neutral. So how am I going to get ALO to be neutral? Okay? I can't just change the charge on aluminum or change the charge on oxygen. So what I have to do is I have to use something that makes this thing neutral. And to do so, I need to use additional aluminum and oxygen atoms. So for aluminum oxide, I've got 3 here and I've got 2 over there. If I add another oxygen, that means I now have a -4 charge, so I'm still off by 1. Okay, so if I add another aluminum here, that's going to give me a +6, so I've got +6 here, -4, so if I add another one, another oxide, this is now +6, that's -6. Now both numbers are equal, they're neutral, now I can form what the compound is. This is aluminum oxide. Alright, and strangely enough, I just gave away the name. So, oxide, that hasn't changed, and this is aluminum. Okay, don't be fooled, the British are not correct in this case, it is not aluminium, it's aluminum. Alright? Okay, so those are the ones that are kind of tricky that you should know. Right? I'm trying to think if there's anything else. And I just remembered, how can I forget? All right? And in this case, what happens when I've got something that has more than one ionic form? Now for nonmetals, generally everything is pretty easy. Okay? Carbon wants to gain 4 electrons. Okay? So the nonmetals, they all have their basic standard charges. Okay, so any of the halogens, fluorine, chlorine, bromine, iodine, all of these things want to be -1. So they all have a -1 charge. right? Things that are in the oxygen row, oxygen and sulfur, both of these are going to be -2 charges. Okay, nitrogen and phosphorus, -3 charges, and for carbon, it's a -4 charge. Okay? Rarely do they deviate from those numbers. Sometimes they do, but for the most part they don't. Okay, so those are their overall charge and the values for ionic compounds. When I get to metals, however, that are transition metals, transition metals have names that are a little bit different because each one of them can have different charges. If I look at iron, iron has two common forms. Iron can be either iron 2 plus as an ion, or it can be iron 3 plus. Okay? And that can throw people for a loop. Copper has two common forms, copper plus and copper 2 plus. Okay? So when we get to those, how are we going to identify between iron 2 and iron 3? Okay? Well, I'm going to do the old school way, and then I'll show you the really easy way of doing this now in the modern age. Okay. For iron 2 plus, what we have is something that is ferrous. Okay? And for iron 3 plus, it's something that's ferric. All right. Now, for copper and other elements, so here's copper plus and copper 2 plus. The name here is copper plus is cuprous. Cuprous. And this is cupric. All right. Now, how am I going to be able to identify which one is which? Notice that the pattern here shifts. That this is not a +2 and a +2. These two things have different names. They always have to relate to what other ionic species are available with that transition metal. Iron is 2 plus, iron and 3 plus. For copper, it's +1 and +2. So these names are reference to the ionic states of each one of the metals. So for ferrous and ferric, us is the lower number, and ic is the higher number. Cuprous is the lower number, cupric is the higher number as far as the charges that are associated with it. Okay? One way I like to think about this, okay, is if I have a charge, a small charge, it's just for us, right? Okay, it's like a date. We're only going to have 1 or 2 charges between us. So it's just for us, it's a smaller number. Okay? If I bring enough of the charge for the entire cast of iCarly, haha, there's a Disney Channel reference for you. But at this point, if I bring enough of the IC for everyone, okay, or it covers it so much that it covers us and makes us icky, okay, that is a larger charge value. So if I have Fe3 plus and oxygen, that's 2 minus, remember, I'm going to put that there just like with oxygen. So what this is rust, and rust is ferric oxide. Okay? Now, you said that you were thinking, Dr. Wayne, this is awfully complicated. Okay? What is the new modern way of doing it? Well, the new modern way is just taking the element and telling us what the charge is. So another way of writing this is just to say iron 3 oxide. I don't know why I didn't think of this before. Okay? Only because people were trying to be fancy back then. But iron 3, this number represents the oxidation state of the metal. Okay? Or the oxidation state being that charge number that's on the iron. Okay? So if I have cupric, if I have cuprous sulfide, okay, Cu2S, okay, so I've got a plus here, and I've got a -2 here. What this is this is going to be cuprous sulfide, or copper 1 sulfide, right? Easy way to name these, and that's basically all I want you to know, or how to name these particular ionic compounds.